Alright, welcome back to Everything Mathematics, and today we're going to look at our fifth and final video for this week and continuing our series of number theory. Yesterday we would have expanded our knowledge by relating the concept of face value and place value, and today we're going to further delve into that whole idea of place value more so by doing some expanding and also some contracting of numbers. Good. So what is our objective for today? We have three objectives for today. So first of all, we're going to look at the big idea behind expanding. What is the whole idea behind expanding, the concept? What can it help us for, or to understand what? Then we're going to also look at expanding various numbers. So we're going to be expanding various numbers, and then we're going to be contracting various numbers. Good? So the big idea behind expanding basically is these two things. So when we expand, it really and truly makes a connection with face and place value. Because when you expand a number, you first and foremost have to know what is the place value of that number, but then also you also are now acknowledging the face value, and you will see why when we do the examples. And of course, it's like a way of spelling out a number. So when you call out a number, let's say 149, that's the number. But when you expand it, it's almost as if you're spelling out the number. So it's almost as if you're giving the 1 its worth, the 4 its worth, and the 9 its worth, right? So that's the whole idea behind expanding. And of course, whatever could be expanding could be contracted. Whatever could be open could be closed, right? So the contracting part of it is like the opposite. You're just going back in the opposite direction, right? Or you're closing back, you're ending up with what you started with. So here we have an example. Let's see if we could solve this one. So I'll teach you first so that we go. So when we expand a number, we're not changing the value, we're not changing the number, we're just opening out the number. When you think of expand, think about that. You're opening out a number. And how we do that is basically by combining the whole concept of place and face value. So here we have the number 345. So firstly, we must know the place value for the 5, the 4, and the 3. So we know the 3 is definitely hundreds, then we know the 4 is tens there, and we know that the 5 there will be our units. And when we understand that, to expand a number, all we basically do is multiplying the face value by the place value, and we add the following numbers. So an expansion of this number will look something like that. And we use brackets just to clear distinction, right? So the face value is 3, and that is being multiplied by 100. Why 100? Because that is the place value it is. And then you add that to 4, which is the face value, and the face value here is multiplied by 10 because it's in the 10th place. Plus, then we have 5, and that 5 will be multiplied by 1 because we're dealing with units. Good? And basically, this is all there is to it. So when we expand in a number, that's the end. Believe it or not, this is the answer. There is nothing else we have to do from that. However, if you want, and I won't advise you to do that on the paper itself, but if you want, you could actually close this back and it's supposed to end up with 345 when you solve this. But I would not do that because that's not the aim of this video. Good? So this is how we expand a number. We just multiply the place value by the face value and we add all the quantities together. Well, that is if you want to prove your answer. Good. And here we have another example now, but here we're doing the opposite. We're contracting a number, we're closing the number. So here the number is expanded for us. So we have 4 times 1,000 plus 0 times 100, 4 times 10. So I notice the order is always in chronological order. You cannot skip a place value. And I'm saying that because of this 0 that I'm noticing here. Sometimes when students are asked to expand a number, they ignore the 0 and they forget, I won't say forget, they completely leave out that place value slot. But you have to be careful. Even if there is a 0, you have to respect the 0's place value so that you would get the right answer at the end. Good. So if we have to contract this number or close this number or avoid the expansion, all we need to do here now is compute. So we just solve the problem. So 4 times 1,000, we compute now. So we just solve that. That is the same as 4,000. So that's 4,000 plus 0 times 100 is 0. Plus anything multiplied by 0 is 0. Plus 5 times 10, that will give me 50. Plus 2 times 1, that will give me 2. Plus 3 times 0.1, that will give me 0.3. 0.3, yes. Hold on, let's take it right. So 0.3. Good. And from here, oh, the point gone. So 0.3. And from here is a matter of just adding all these numbers. You have to be very careful with the decimal point. A matter of fact, I'll do something that we were taught in primary school. So I'll just place all these values in the order in terms of decimal. So we have 4,000.0. Then we have 0.0. Don't mind my point, but I really want it to be spelled. Then we have 50.0. Then we have 2.0. And then we have 0.3. 0.3. And we add all these numbers. Of course, we could use them zeros to occupy the other place values, but it's not a must. And if we add this number, you see that we'll end up with 3 here. Our point is here. Then there is a 2, there is a 5, there is a 0, and there is a 4. So I just brought down all these values, right? So the 4 came down, the 0 came down, the 5 came down, and when the 2, you could see that row there, right? But what I wanted to notice is this. Notice, and that is how important it is to acknowledge each phase and place value. Some students generally believe that the 0 doesn't matter, so you don't have to multiply by the 100. But notice if we did not do that, we may not have ended up with the same value for 0 here. Notice the 0 is under the hundreds. So that is our way to verify. 4 is on the thousands, so we multiply the 4 by the 1,000. 5 is tens, 2 is units, and the 3 was 0.1, so that's tens. And that's basically how we contract. So to contract, all we really need to do is close back the multiply and solve. So it's a basic arithmetic. Simplify the answer, and you should end up with the final answer. So one is really and truly the opposite of the other. So here we have sum. Let's do sum for practice. And of course, this is the part of the video where you could pause it here and see if you could handle these on your own. Of course, I will not pause it. I will move on. This is a video for me that I'm doing. You can pause here and then continue, right? So, moving on. I'm expanding 270. So again, I know the 2 is in the hundreds. I know 7 is in the tens. And I know my 0 is in the units. But remember, we cannot ignore it. We cannot ignore it just like that. So that will simply be 2 times hundreds, because 2 is in the hundreds, plus 7 times 10, because the 10 is in the 7 is in the tens place, and plus, don't ignore this, the 0 times 1. Don't worry, it will still get 0, but we have to state it. If we ignore this, so if you don't put this, for example, let me say your answer stops here, in an evaluation activity, you will not get full marks, because you totally ignored an entire value. Don't say 0 means nothing, so you don't have to put it. Yes, that is true, and yes, it may not affect the value at the end of the day if you multiply out, but in terms of understanding the concept, we must include. Moving on, another one. So we have 1, 3, so 13.67. Notice that the 13 is 2 numbers, and then we have a decimal. And by the way, just as this might be here, remember after numbers, after the decimal value, you have to call each one single. So some persons might be tempted to say 13.67. But this 6 and the 7 does not add up to 67. It's not 67. It's actually 13.67. Because this is tens and then we have hundreds. So that will never be 67. 67 is when the 6 is in the tens and the 7 is in the units. That will make 67. That was just a side note, right? So let's try this one. So again, my first one, that's in the tens. So that's 1 times 10 plus my 3 there is in a unit, so that's 3 times 1, plus, I'm going to decimal places now, so it's 6 times, you could either put 0.1, or if you want, you could put 1/10. If you like your fractions, you could put 1/10. At the end of the day, it doesn't matter because we're not simplifying. If they ask us to expand, we don't have to simplify, we just have to expand, and that's what we're doing here. So you don't have to worry about working it back up. And here will be 7 plus 0.01. Or of course, you could put 7 plus 100. You could do that too if you want. That's completely up to you. That's optional there, right? Optional stuff there for you. Let's try the next one. Moving on swiftly. So we expanding 1005.2, and again it's 1000, so I'm not starting with 1000. So that will be 1 multiplied by 1000. We get that. Plus, remember I'm respecting my zeros. So it's the first 0 there is 0 times 100. And the second 0 there is 0 times 10. That's the place value in which it is. Plus, the 5 is in a unit. So it's 5 multiplied by 1. And then I add that to the 2 multiplied by, let's do a tenth here. 2 multiplied by a tenth. And remember, as I just did there, it could be 0.1. You don't have to worry about simplifying it. We just asked to expand, so we just expand it there. And that's our answer. That's as far as we could go. I hope you got that when you attempted it on your own first, if you did yours before you started looking at mine. And then last but not least, or not last, sorry, I think we have one more after this. We have to contract this. So 4 times 100, so simplify. So hold on, let me change the color. So let's go with what? Green. So 4 times 100, we have 400 plus 0 times 100, that is 0, plus 0 times 10, that is, there's a mistake here. Yep, there's a mistake here. And I'll correct it one time. I believe here this value here is supposed to be 1000. Given the order of this sequence going down, yes, so I'll make that correction right there. Don't worry, mistakes do happen. So as a result, then we're supposed to have 4,000. 4,000 plus 0 plus 0, because 0 times 100 is 0. 0 times 10 is 0. 5 times 1 is 5. This answer looks very familiar. Plus 6 times that is 0.6. I think the first one was 4,005.3, but I can't remember. I have to look back. Right, but this one's supposed to give us 0.6. And when we add all this, we're supposed to get 4,005. Nah, I think the other one had a 2 somewhere. 4,005.6. This here is supposed to be our final answer. Try that again. This here is supposed to be our final answer, unless I add it wrong. Of course, if you can see it like that, you could most likely always use a calculator or just state it down as I did earlier, put points under points, and usually you can't go wrong like that. And then we have our last question here. And this one is pretty straightforward. So we have 1,000. Let me see what color. Let's go with purple. So we have 9,000 here because it's 9 times 1,000. So that's 9,000 plus 500. Yes, 5 times 100 is 500 plus 10 plus 8. Yeah, this one is pretty straightforward. So 9,000 plus 500 is 9,500 plus 10 is 9,510 plus 8 is 9,518. So our final answer here is supposed to be 9,518. That is what we would get after we expand that expanded number at the top there. So again, it's a very simple concept. Of course, with practice, you'll get even better. But that will bring us to the ending of this week and the ending of today's video. So again, feel free, as always, to like, share, and subscribe. And until next week, Monday, see you again.